Now here I'm going to look at the similar polygons and the examples to what we learned about in the actual lesson. First thing is, are these two triangles similar? Well, I go back to similar polygons have to have corresponding angles being congruent. I'm going to start here and I'm going to start here. They're not congruent, so these triangles are not similar. Say no. Go on to my next one. Now, are these triangles similar? And I'd start off by looking at angle B is yes congruent to angle S. That's a good thing. But now I can't tell if angle C is congruent to angle T or if it's congruent to angle R right away. So at first glance I would say no, there's not enough information. But when I go through here and I start thinking a little bit more, I could find the measure of angle C. That's going to come out to be 40 degrees, because remember all three of those angles have to add up to 180. And now I look at it and go, well, angle C and angle T are congruent, so that's good. But then I'd go, well, I don't know the measure of angle R right off the top of my head, but I could find it because I do know the two measures of angle S and angle T, which is going to allow me to say that this angle measure is going to be 60 degrees. And now I go, well, this angle is yes now congruent to this angle. So my angles, my corresponding angles are congruent. There's my first check. Now I got to look at the sides, match these up. I'm going to look at my 5.2 unit side. That's going to have to match up or correspond to the 3.9 unit side. Write my two little fraction bars for my other ratios. I'm going to look at the 7, and I also have to have the 8 for my other two. Now, the 7, that one's going to match up with the 5.25. Oh, that's not what I wanted. I don't know what happened there. We'll try to undo that. Alright, try this again. That has to match up with the 5.25, and the 8 is going to match up with the 6. Now I look at this, and I can't tell if those ratios are equal, so I'm going to grab my calculator. Now when I type these into my calculator, if I take 5.2 and divide it by 3.9, I end up with 1.33, actually 1.3 repeating, so that 3 is going to repeat. This comes out to be 1.3 repeating. Just so they don't confuse, I'll make them all look the same. And this one also comes out to be 1.3 repeating, which tells me those are easy now for me to tell they're equal. These are equal, which tells me that my sides are proportional, my corresponding angles were congruent. Are these two triangles similar? Yes, these two are. I've checked all my corresponding angles to be congruent, and I've checked my corresponding sides to be proportional. Now in this one, notice it tells us that the two pentagons are similar. We know they are. We don't have to check them. We know they are. And we want to find the value of x and y. Well, if they're really similar, that means that the corresponding angles are congruent, which we can see, and the corresponding sides are proportional. So what I'm going to do is I'm just going to start with x. I'm going to say, well, I'm going to start with x. If the sides are proportional, I'm going to set up a proportion. I'm going to put that x in called the top left spot, and now I just have to match things up. I want this left ratio to be corresponding sides. So my x came from the side that was between, or the included side between the triple arc and the quadruple arc. So I come over to my other polygon, between the triple arc and the quadruple arc is the 3, and this is going to have to match up with the 3. Now I'm going to go back to my pentagon that had the x in it, and pick a side that I know the length of, which is going to be the 6 or the 8. But then I want the corresponding side to the 6. I need to know that length, or if I pick the 8, I need to know the corresponding side length of that one. If I pick the 8, that corresponds to the y plus 1, and it's not good for me to have an x and a y in an equation, so that doesn't work. But if I pick the 6, that's going to correspond to the 4, and now I have a proportion that I can solve. Go through and solve. I'm going to end up with 4x equal to 18. I can solve my equation, and I find out that x equals, oops, not 2.5, excuse me, 4.5. So I found x. Now I need to calculate the value of y, and it's not going to be any different. I'm going to do it pretty much the same way. I like to first start with my proportion, and I like to put my variable right away in there. So my variable to start off this time is y. Now I look at it, and the y plus 1 is the length of one side of my larger pentagon. I have to now find the corresponding side to that in the other pentagon, which would be the 8. So this is going to be over 8. Those are corresponding sides. Now I got to come back to my second ratio, pick a side length that I know. Well, I'm going to go with the 4, because I know that that's going to correspond to the 6. Now I'm going to solve my proportion. Cross multiply. Remember, I got to take that 6 and multiply by the y and the 1, so I'm going to get 6y plus 1 equal to 32 when I go this way. Continue to solve my equation. Get rid of that 6. Now I have 6y equal to 26. Divide both sides by 6. And I find out that y is equal to 13/3. Or if you wanted to convert that into a decimal format, that would be approximately 4.33. And there I found the value of my x and my y, depending on how you want it in fraction format or decimal format. And then my last example here, a little story problem. This one tells us that I have rectangle WXYZ being similar to rectangle PQRS with a scale factor of 1.5. Now this is important on how it's written. This rectangle is similar to this rectangle, which becomes helpful when we look at scale factor. It's right here. Scale factor of 1.5. Now remember, a scale factor is a ratio of corresponding side lengths. So I have a ratio. I'm going to turn it into what looks more like a ratio, 1.5 over 1. Now remember, this is essentially what I have highlighted up there. I have green to blue. So there's my ratio. Keep that in mind. Now it says if the length and width of rectangle PQRS are 10 millimeters and 4 millimeters respectively, what are the lengths? What are the length and the width of rectangle WXYZ? Well, I have this ratio here. I'm going to use it. Now remember, this is green over blue essentially. Now the problem tells me that I know, I'm going to look at length first. I know the length of rectangle PQRS, which is like what I had in blue. So the length is 10 and the width is 4. Now I'm working with length to start off with. So my 4 meters, I can put in the denominator of this ratio, because if you remember back here, my 1.5 went with the green, the 1 went with the blue as far as what I'm using for color up there. Now I don't know this. I don't know the length. Now I have a ratio in 1.5 over 1. I have a ratio in L over 4. They're set up the same way. Therefore, these two ratios are going to have to be equal. And now I can solve my proportion. This proportion is going to be pretty straightforward. L is going to equal 1.5 times 4, which comes out to be 6. And remember, the label here, everything was dealing with meters. So my length of my rectangle WXYZ is going to be 6 meters. Now I can do the same thing with dealing with the width. I can use this scale factor again, clone it, and I can set up a proportion for this one. Now this time I know that my width is 4 meters for called the blue one, or rectangle PQRS. And I'm looking for the width of that rectangle. We know that these ratios have to be equal. Solve my proportion. So W, or the width, is going to equal, oh, I screwed that up, didn't I? Well, this is the width, I just did this. This is going to be 6 meters. Sorry about this. I'm going to have to go back and do a little fixing. Hopefully somebody noticed that. This number right here should have been 10 because I was dealing with lengths, which is going to change this. Now I have to take 1.5 times 10, and the length, sorry about that, should have been 15 meters. So the length and width of my rectangle WXYZ will be 15 meters and 4 meters. And that's going to end my examples dealing with similar polygons.